Hi Year 4 and welcome to Wednesday's maths lesson. Before we go into today's learning, based on yesterday's learning, can you have a go at these? So you need to work out what the question marks could be in both of these questions for me. So pause the video, have a go, and then come back to me and we'll go through the answers. So for this one, 6/10 is the same or equivalent to 60 100ths. And then this one, 72 100ths is equivalent to 7/10 and 200ths. But you could have also had 6/10 and 1200ths, or 5/10 and 2200ths, and so on. Okay, so there were different options you could have had for that one, but the main one would have probably been 7/10 and 200ths. So today then we're going to identify tenths of numbers and write decimals correctly. So we are going to be focusing on decimals today using our knowledge from the past 2 days on fractions. So your star words today are fraction, numerator, denominator, tenth and decimal. So let's learn then. Looking at this place value chart or grid, what would the question mark represent? So we have our tens, we have our ones, and then what value of the digit, say if there was a 4 here, what would the value of this part of the grid be? So it would be tenths, okay? That is where our tenths come in, which is also the same as this. Okay, so tenths, which is also that, is what comes after here. And you'll notice there's a dot here as well. So any number past this is a decimal because it's gone into the tenths. Okay, so you have your tens, your ones, decimal point, and then it goes into your tenths. So let's look at this one then. So we have this grid filled out. We have a 4 in the tens, a 1 in the ones, and a 7 in the tenths. So what is the value of this digit? And how, using this sentence stem, could you say how many tens it has, how many ones, and how many tenths? So the value of the digit in this place value grid is 41.7 or 41.7, however you'd like to say it. So it has 4 tens, 1 ones, so it should be an S on the end, and 7 tenths. So it's 41.7, 41 decimal point. So moving on to this then, what does the place value grid show now? So how many ones do we have, and then how many tenths do we have? So remember before I said a tenth is this. It also can be represented as a decimal as this. Those are the same, okay? So each of these is one decimal, 1/10, sorry, let me start. It's 1/10 as a decimal, there we go. And this is 1/10 as a fraction. They're the same thing, just written as a fraction and a decimal. So how many tenths do we have here? There are 3 tenths, and we would write that as 0.3, because if you add 0.1 and 0.1, I'm just adding these counters together. You would add the zeros, still 0, and then you would add the ones, 1, 2, 3. So it's 0.3, okay, or 0.3. So now it's your turn. I want you to have a look at the place value grid and find out how many tenths there are and how it would be written as a decimal for me, please. So there are 1, 2, 3, 4, 5 tenths. And as a decimal, that would be 0.5. Okay, so there are 5 tenths, which as a decimal is 0.5. Okay, moving on to our developed learning then. Let's get that away. So I said before that 1/10 could be written as 0.1, or it can be written as a fraction as well, like this. So if we have 7 tenths, what would that be as a decimal? Sorry about the decimal point being so big, I don't know why it's so big. I've drawn this to help us. So here I've got 1, 2, 3, 4, 5, 6, 7 tenths, but I've just written them as a decimal instead of a fraction, so they could also have 1/10 written inside them. And if we add them up, we'd have 1, 2, 3, 4, 5, 5, 6, 7. So 7 tenths as decimals would be 0.7. 0.7, because if you just add all up in your ones column, you still have nothing, there's still a 0. If you add all your ones up, you'd get 7, so there's 0.7 tenths, or so there's 7 tenths, but that is written as 0.7. Sorry, it's quite confusing to explain, so I'm sorry I keep making mistakes. So now it's your turn. What I want you to do is see if you can fill in what these would be. So what decimal would be equivalent or the same as 2 tenths, and then 8 tenths. And then this one, can you write 0.9 as a fraction and 0.1 as a fraction? So have a go at that, and then we'll go through the answers. Okay, let's go through the answers then. So we have 2 tenths, and that would be equivalent to 0.2. This one would be 0.8. This one would be 9 tenths, and this one would be 1 tenth. Okay, so that means they are the same, they are equivalent. Okay, so now it's your turn to have a go. I'm aware that this is quite, well, I'm hoping it was quite straightforward for you, and some of you may have found it a bit easy, but the point of going through this is just so we are really confident with it before we go on to kind of the more problem-solving-y stuff. Because I want you to make sure that you really understand this before we move on. So you have some questions today. I'm also sorry that it's lots of questions on the video. Unfortunately, on Mathletics, there's not very many decimal activities. So there will be some set, but not very many because there isn't many. So I'm really sorry about that, but unfortunately, there's nothing we can do. So this is Group 1's first set of questions for today. As usual, they are also on the website if you want to print them off. This is Group 1 second question. This is Group 1 and 2. And then Group 2's questions. And then once you've done them, if you want to come back and go through the challenge, then feel free. This is the challenge. And once you've had a go, come back and we shall go through the answers, and I'll explain how I worked out all the answers with you. Okay, welcome back. Let's have a look at some of the answers then. So for Group 1, what numbers do the representations show? So we have 2 tenths, because if you have 1 tenth and another tenth, that is 2 tenths. So that would be 0.2. Part B shows 1, 2, 3, 4 tenths, which is 0.4. The white cubes represent 1, 2, 3, 4, 5, 6, 7 tenths, which is 0.7. And the grey cubes represent 3 tenths, which is 0.3. The white beads represent 4 tenths. I'm assuming there's 10 there. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, which is 0.4. And then the grey beads represent 6 tenths, which is 0.6. So I'm hoping that was all quite straightforward for you. Second part for Group 1 then, complete the models below to show each decimal number. So draw counters to show 0.3. So you should have drawn 3 counters in the tenths because there are 3 tenths. You could have written this in each counter, a tenth, or you could have written 0.1 in each counter, but either way it doesn't matter too much. And then this one says the 10 frame represents 1 whole. Draw enough counters to represent 0.8. So if this is 1 whole, it's been split into 10 equal parts. So I'm going to draw 8 counters, and each of them is worth a tenth. Okay, so you can write it as a tenth or 0.1, and that would represent 0.8. Group 1 and 2 then is 1 tenth is equivalent to 0.1, 0.3 is equivalent to 3 tenths, C is 7 tenths, and D is 0.6. Sorry. There we go. And the second part of Group 2, it says Emma has written the value of the place value counter as 1.10. Is she correct or incorrect? Explain your answer. So she's actually incorrect. Because the place value counter shows just 1 tenth. So if you had a place value grid, if I do tens, ones, decimal point, then tenths. Sorry, it's really hard to write using this. This is a really unneat grid, sorry. If you have 1/10, that would just be one counter there, wouldn't it? But her number is 1.1/10, so that would mean she would have one counter here and then one counter here. So Emma's value is in green, but the actual counter's value is in red, and you can see that Emma has got 1, 1, 1, which is in the ones column, very confusing. But there's no 1 here, there's only 1/10. So therefore she is incorrect. Hopefully I explained that okay. I'm not the best at explaining stuff, things sometimes, but hopefully that was all right. This one, Alex thinks of a number. It is less than 1. It has an even digit in the tenths column. It can be made with more than 7 counters on a 10 frame. What number is she thinking of? This is a tricky one because this is a question that it takes a while to think about it, and you've really got to actually think, okay, what do I need to know? So it's less than 1, so therefore it's going to be a fraction or a decimal. That just means it's less than a whole, okay? It has an even digit in the tenths column. So the tenths column is an even digit. So it's either going to be, it could be 0.2, it could be 0.4, 0.6, 0.8. It can be made with more than 7 counters on a 10 frame. So therefore, if we had a 10 frame, 2, 3, 4, 1, 2, 3, yep, 5. So I've drawn a 10 frame. It can be made with more than 7 counters. So we need to have at least 7 counters. So 1, 2, 3, 4, 5, 6, 7. So bearing in mind each of these counters is worth a tenth or 0.1. It could be 0.7. However, it says that there needs to be an even digit in the tenths column. So if we add another one, it would be 0.8. Now 0.8 is less than 1 because it's not a whole. It could also be written as 8/10. It has an even digit in the tenths column, 8 is even, and it can be made with more than 7 counters on a 10 frame. So therefore it could be, or she is thinking of 0.8, because the next one along would be, if you filled it all up, it would be 1 whole, but it says it's less than 1 whole. Okay, those kinds of questions are quite tricky and they can take a while to get your head round, so don't worry too much if you found it a bit tricky. And then finally the challenge, it says who is correct. So Annie says 1.2 is equivalent, that means the same, to 1 whole and 2 tenths. Dexter says that 1.2 is equivalent to 12 tenths. Explain why. So you need to pick who is correct and then explain your answer. Okay, so I've just drawn a place value grid just with ones and tenths because that's all we're looking at the moment. So Annie says 1.2 is equivalent to 1 whole and 2 tenths. So I'm going to put counters in to show 1.2 first. So in the number 1.2, we have 1, 1. So I'm going to draw 1 counter here, and we have 2 tenths. So 1, 2. Okay, so this is equivalent to 1 and 2 tenths. Okay, so this could have a 1 in it, and these counters would have a tenth or 0.1. So she is saying that it's equivalent to 1 whole and 2 tenths. So she is definitely correct because there is clearly 1 whole and 2 tenths. You can see that in the place value grid, so Annie is correct. Dexter says 1.2 is equivalent to 12 tenths. Now, if we were, so thinking back to, I think we did it when we looked at multiplication, if we had a tens column and we had a 10 and we were moving it into the ones, how would we move? So I'll just draw it on. How would we move a 10 into the ones? If we were moving that into ones, what would we do? We would add 10 counters, wouldn't we? So therefore, how would we move a 1 into the tenths? If we were to move that over, how many tenths would we have to add? How many tenths are in 1 or 1 whole? It's 10. So you would add 10 counters. So 1 is the same as 10 tenths. Okay, and that comes back to the our fraction work where 1 whole the same as 10 tenths. Sorry about that. So I've drawn 1 extra, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all I've done is exchanged 1 for 10 tenths. So I'm crossing that out because that doesn't exist anymore because I've moved it over here. So now we would count how many tenths we have, and we would have 12. So therefore, they are both correct because this is still showing 1.2. It's just the counters have moved into the tenths. Dexa has just exchanged the ones into the tenths column. Okay, so hopefully that made sense, and hopefully by drawing it, you're able to see it as well. That's everything for today. Thank you for watching, and yeah, thanks.